Hey, what's up? So this is going to be a small continuation of the series that I started making about my internships, except I'm going to go and refresh a previous video that I made on my previous channel. It was regarding a class that I took back at UC Irvine, and it was MA52, which was a SolidWorks design class. And there our final project was to actually create our own assembly of whatever sort of mechanical system that we wanted. At first, I had known that I got an internship at Cummins, so I wanted to actually model a 6BT. 6BT is a pretty great machine. It's been around for over 25 years. Great 6-cylinder diesel engine. So this class required me to make a small little 1-minute video about what I did in the class. I was just gonna re-upload it, but I said, why not just update it and congratulate SpaceX on all the accomplishments that they've done over the past couple of years. This video was back in 2017, so since then they did not release what probably they were working on at the time, which was Starlink and which was also Starhopper. So those two are the biggest things that are going on in the press right now. That's what's going on right now in the engineering community. But back in 2017, that was right around when they just landed their Falcon9 rocket. And if you haven't seen that, I'm gonna put a clip right here. And keep in mind, this was not SpaceX all the time. When I first visited the facility back in 2012, so the story is pretty interesting, where I was actually in my honors trigonometry and pre-calculus class in high school as a junior, and I was on the cutoff to go on a field trip to SpaceX. It was between me and another guy in the class, and whoever got the highest score on the next test would end up going on the trip. I will never forget this day. I stayed up until 4 in the morning, which was unheard of back in high school, to study for this test, and I ended up getting a much higher grade than the other guy. I went to the facility and I was mind blown. I will never ever forget the tour that I had and the feeling that I had seeing people in there working on such interesting things. To put it plainly, and to be honest, the only other time that I felt this way was when I visited JPL's facility back when I did the NCAS program. But after that day, I kind of made it my mission to get a job at SpaceX, and I really feel that everything that I've done in my experience has been geared towards getting an internship at SpaceX, or now, since I've graduated, a full-time position. Fast forward about 6 years, I finished community college, I transferred. The odds are all against me, but guess what? I'm a persistent little I decided upon making this project about the Falcon9, which was a rocket that was being manufactured in the facility when I visited. I was very inspired by this, and I went into great detail in trying to really get all the parts right, get all the assemblies right, and it was one of the most exciting and difficult times of my life. At that time, I was a little discouraged coming from community college and going into the university. Even though I had 2 internships under my belt, I did feel that I had to prove myself, and this was a perfect opportunity to do so, and I did it. And if you can see in the model right here, I designed the Falcon9 rocket, and the rocket consisted of a payload capsule, which was at the time Dragon V1. Now they have V2 and they're working on V3. I had 9 rockets. There was their 9 Merlin rockets, which were one of the most powerful rockets at the time. Now they have the Raptor. They have a lot more powerful engines that they're producing. And also just explain the unique control system that needed to be implemented into the system to actually land it back safely onto one of their ships. The modeling took about 60+ hours to complete, and it was due to the complexity of the parts. There was a lot of reference planes that I had to use, a lot of revolve cuts that I had to implement, 3D sketches and sweeps to make sure I had all the tolerances right on the model. And at the end, I realized that I wanted to take it one step further and update it to what they were doing at the time, which was trying to successfully land a first stage booster back onto a drone ship. So I ended up designing the stability fins that they use to actually maneuver the first stage back onto orbit in addition to the Draco boosters that they have on board. I realized there was going to be an immense amount of drag that was going to be applied onto those stability fins, so I decided to do an analysis on it and do a simulation of the forces that would have been found when coming back into orbit. This was a very great opportunity for me to also utilize some FEA that I had already just learned, and also go into further detail of what the rocket is supposed to look like. So in addition to doing simulation on the stability fins because of the immense amount of drag that was going to be experienced by it, I also went ahead and designed the Dragon V1 capsule that would be attached on top of the Falcon 9. The Dragon V1 was not an easy part to be modeled just because of the complex angles and the reference planes that I also had to use to get the appropriate dimensionings that I found online. But at the end result, I think looked amazing. It looked very similar to what they actually were sending into space, and it really gave me more of an appreciation for the engineers at SpaceX and the barriers that they're breaking. I give so much credit to the engineers at SpaceX just because of the level of persistence and resilience that they've showed over the past 10-15 years. They're the ones that are really pushing the limit of engineering, and furthermore pushing the limits to themselves. I know Elon Musk is a huge advocate for doing more than is expected of others, and I really do believe in that, and I've been following Elon's message for 10 years now, and I really got to thank Elon because he is probably the closest thing that we have today to Nikola Tesla, to Steve Jobs. He's really the one that has been pushing the boundaries for engineering, for humanity, and just for exploration as a human being. Thank you to the engineers at SpaceX for building such an incredible machine and system for me to model for my class. And also thank you, Elon Musk, for teaching an individual like me that the limits really are endless. I hope to one day sit in your office and have you yell at me for a design constraint that I made or for control systems that I designed, because I really want to work for you. And I think this quote applies to SpaceX more than any other time in history, even though it wasn't said by Elon Musk. And it is the people that are crazy enough to change the world are the ones that actually do. So go out there, change the world. Like always, stay boosted.